Today we're going to continue looking at our indice laws, and I'm going to start with looking at index law 3 and the zero power. Now index law 3 has to do with brackets and then the indice on an inside of the bracket and an indice on the outside of the bracket. So as you can see at the top here, we have index law number 3. The best way to show you is to actually do an example. Now, here we have in part A of example 9, we have x to the power of 5 in the bracket and then the power of 4 on the outside. Now, what the law tells us is that the 5 will multiply with the 4. So those two indices multiply together and it becomes x to the power of 20. So why does this happen? Well, with the indice on the outside of the bracket, it's saying that x to the power of 5 will be multiplying itself 4 times. So if I was to write it out the long way, it would look like x to the power of 5 times x to the power of 5 times x to the power of 5 times x to the power of 5. And if we can then refer back to index law number 1, where we're multiplying the same base number, that means we add our indices together. 5 plus 5 plus 5 plus 5 gets us x to the 20. So this is why the rule works, and we multiply 5 by 4. So let's make it a little bit harder. Let's have a look at B. Notice that the 3 is on the outside of the bracket. So therefore the 3 is not the one getting squared. The y to the 5 is inside the bracket and that is what's getting squared. So I'm just going to write it slightly different to what the question is, just to show you that it is very much separate, the squaring from the 3. So now you just deal with the square and the y to the power of 5 using our index law. It's 5 times 2. Therefore, our final answer is 3y to the power of 10. That's as simple as it can go. However, let's add in a question just to show you if I had put the 3 inside of the bracket. So if I had put the 3 inside of the bracket, and then we still had the indice of 2, so the squaring on the outside of the bracket, this now means it includes the 3. So everything inside of that bracket will get that square. Since the y already has the power of 5, we go 5 times 2. The 3 gets a square. 3 squared is 9. So therefore it would be 9 to the power of 10. And that is how that would look different if it was in brackets. So bear that in mind when you're in a test situation as to where the brackets are and whether it's going to be squared or not. Let's have a look at the next slide. We're having a look at our power of 0. The key thing is anything to the power of 0 will equal 1. Okay, so that's what you need to remember. But don't be fooled. There are ways in which we can actually kind of trick you into thinking the answer is 1, but it actually isn't. So we'll have a look at this. In our very first question in example 10, it's negative 3 in brackets to the power of 0. Now anything to the power of 0, you guessed it, is 1. So the answer to A is 1. If you don't believe me, please check it on your calculator because anything to the power of 0 is 1. So this is why with B you need to be careful, because notice now that the negative is on the outside of the bracket. However, we've got 5x on the inside of the bracket. If I was to apply index law number 3, basically the 5 would get a power of 0 and the x would get a power of 0 to get rid of that indice on the outside of the bracket. But as I said, anything to the power of 0 is 1. So it's going to be negative times 1 times 1, because we know what's happening between the 5 and the x is multiplication. The negative next to the bracket, what's happening between it, is multiplication. So therefore, our final answer is negative 1. So really bear that in mind. Notice where your indice is at, otherwise you will get this answer wrong. With C, there are brackets and there's no brackets. Bear in mind that the y in the first one, so 2y to the power of 0, that y, the 0 is only on the y, not on the 2. What's happening between the 2 and the y to the power of 0 is multiplication. So it now becomes 2 times 1, because anything to the power of 0 is 1. Subtract 3 to the y, which is in brackets, to the power of 0. So that would be 1, because anything to the power of 0 is 1. Follow your BIMDAS, multiplication before subtraction. 2 times 1 is 2. Subtract 1 gets me 1. So my final answer is 1. Now that's just a coincidence that this has actually worked out as an answer of 1. But we could have gotten an answer of 3, 4 or 5 if we had changed that 2 in front of the y to be a different number. So take your steps, each step do something, and don't rush it, otherwise you may make mistakes. With example number 11, we're now combining some of these laws that we have learnt today and previously. Here we have in the very first one in A, in example 11A, we've got our brackets and we've got our indices. So remember, you multiply your indices together. So it's going to be x to the power of 6 times x to the power of 15. This then leaves us with using index law number 1, where remember, we're adding our indices together because they are the same base number, being x. So 6 plus 15 gets me 21. So it's x to the power of 21. With B, we've got brackets on the top with our indices, so let's simplify that first. M to the power of 3, and then bracket the power of 4. 3 times 4 gets me 12. So m to the 12 at the top, and I've still got m to the 7 at the bottom. Because now it's dividing because of our fraction line, we're using index law number 2, where we subtract 12 and 7 from each other, and we end up with m to the power of 5. For C, let's tighten up what's happening at the top and make it a bit neater before we deal with what's happening at the bottom. 4 times 3 gets me 12. X squared times x cubed gets me x to the 5. Notice there are no brackets, so I'm not multiplying my indices, you're just adding them. That's just index law number 1. 6x to the power of 5 is at the bottom. Now what we can see is happening is we end up with 12 over 6, so that leaves me with 2. x5, so it's 5 take 5, which is x to the 0. Be careful. Remember, anything to the power of 0 is, you guessed it, 1. 2 times 1 is 2. So if you would actually put the answer of 2x, you are incorrect, because it's 5 take 5, which is 0. Watch out for that. Let's look at our next slide, and this is for index laws number 4 and 5. This is basically still dealing with brackets, but we might have some timesing and some fractions happening inside of the bracket, and then the indice on the outside. Your index law for 4 is up here, and your index law for 5 is up here. These are just general rules that we can follow. Looking at example 12a, everything inside of that bracket will be getting the power of 3. So it's going to be 5 to the power of 3 and b to the power of 3. We're going to complete that calculation of 5 to the power of 3, which gets me 125, and then b to the power of 3 stays as is. There you go. Fairly simple since we'd already looked at index law number 3 before. Now let's have a look at b. We have negative 2x cubed y in bracket, and then we have y to the power of 4 on the outside. So everything on the inside. Now because this is a negative 2, notice that I'm actually going to put this in a bracket to the power of 4, and yes, that does change things. X to the power of 3, 3 times 4 gets me 12, and y now has to the power of 4. So remember, I have mentioned to you before the difference between a bracket and no bracket with a negative. If there was no bracket, this is how it would look above here. Your answer will always be negative. Whereas with, so that would be negative 16, sorry. Whereas with this one, it's negative 2 times negative 2 times negative 2 times negative 2. And then we've got timesing of x to the power of 12 times y to the 4, which we'll just add on at the end. So negative times a negative times a negative times a negative actually becomes a positive. So therefore it's a positive 16, x to the 12, y to the 4. So be mindful of your negatives, put brackets around just to help you remember that it goes with it. With C, I'm just going to put it to this side and we'll do it up here. The 4 is on the outside, and that's not getting the power of 5 because it's on the outside of the bracket. Don't need to worry about it too much, it's just going to stay as is. The power of 5 is going to join on with c to the squared and d to the cubed, so it's going to be c to the power of 10, 5 times 2, and 3 times 5, which gets me 15. And that's as simple as you can go. Let's have a look at our next slide. This will be our final slide for today. This is now when we have our fractions, and then we actually have to apply the indice, which is on the outside of the bracket. So we have A, example 13a, we've got 6 over b in brackets. Once again, that means the 6 is going to get the 3, and the b is going to get the 3. So let's just evaluate the 6 to the power of 3, which gets me 216 over b to the 3. That's as simple as it can go. Making it a little bit harder, let's have a look at b. Everything inside of that bracket is getting that negative, 4 on the outside. So it's going to be negative 2 to the power of 4. A squared, so 2 times 4 gets me 8. 3 to the power of 4. B to the power of 4. And C, 3 times 4 gets me 12. So I'm just going to do this first step. This will just help you in making sure you don't make silly mistakes. So take your time, it's okay. So I end up with 16 a to the power of 8 at the top over 81 b to the 4 c to the 12. I look at my numbers 16 and 81 and I actually cannot make that any more simple, so that's as far as I can go. It's as simple as possible. Okay, so C is a little bit more complex and takes a little bit more time to do, but as I keep saying, just take your time with it to avoid making mistakes. Step 1, get rid of the brackets. So it's going to be x to the power of 6, y to the power of 9 over c to the power of 3, multiplied by x to the power of 4, c to the power of 4 over y to the power of 4. Now we can actually multiply our top bits together, then multiply your bottom bits together. This is just using your normal rules of multiplying fractions. So I'm now going to use index law number 1. So my top now becomes x to the power of 10, y to the power of 9, and c to the power of 4, over c to the power of 3 and y to the power of 4. Now I can apply index law number 2, which is doing some cancellation. So I end up with x to the power of 10, y to the power of 5, and c. Those were all left at the top of my fraction, so I don't need to write it in a fraction anymore, and that becomes my final answer. Hopefully you found this useful. If you have any questions, feel free to ask. Good luck.